Hi everyone, this is Nithin Heraje from AG Institute of Engineering and Technology, Department of Computer Science and Engineering. Today we are going to discuss how to identify the interior and exterior region of a polygon. First of all, why we want to identify interior and exterior region. Say if you want to draw a polygon with the intersecting edges, then it is difficult to identify or to fill which block of the polygon. So it might be a difficult task when there is a polygon with intersecting edges. So the internal region of the polygon, we call it as interior region, and we designate as exterior to the object boundaries. So to do this, we use two algorithms. The first one is odd even rule algorithm, and the second one is that the non-zero winding number rule. So we'll look into each one of the algorithms one by one. The first algorithm is even odd rule, which we call it as odd parity rule, or also it is termed as inside outside test. So what does this algorithm say? It says we first draw a line from any position P to a distant point outside the coordinate extents of the closed polyline. So if you look at this diagram, let me consider this as the point P, which is extended outside the coordinate extents till here. Then you need to count the number of line segment crossing along this lines. So if you look at this particular line here, we have two crossing edges, one over this and one is this one. So there is two crossing edges for the line that we have drawn from a position P. So the algorithm says in the third point, if the number of segments crossed by this line is odd, then P is considered to be an interior point. Otherwise, P is an exterior point. So the first line which we have considered this, it crosses with two lines, which is nothing but even number of lines crossing the edge. So that will be this region will be treated as exterior region. Well, we have one more line drawn from this point to here. Again, there are two line segments crossing, so again this particular region is nothing but the exterior region. And there is one more line that has been drawn from this point towards the outside the boundary. So if you look at this, there is only one line that is intersecting this edge, which means there is odd number of lines intersecting the edge. So this particular region, we call it as interior region. So this is considered as interior region. Okay, so let me take one more example. Let me take a line from this point towards the outside of the region. So in this case, we have one line that has been intersecting, and hence we call this region as interior region. We call it as interior region. Okay, let me take one more example over here. So this point, if I take it as, if I check, even there it is only one line going to intersect, which is nothing but odd number of lines intersecting, and hence we call that region as interior region. So in a summary, it says you draw any line from a point towards the outside of the polygon such that the number of lines intersecting that line which has been drawn, if it is intersecting odd number of lines, then the region where you started the line with point P is called as interior region, and if you are going to intersect odd number of lines, then that region is called as exterior region. Now we'll move on to the next algorithm, that is non-zero winding number rule. So first of all, let us see what is that winding number. So winding number is nothing but the number of times that the boundary of an object winds around a particular point in the counterclockwise direction. So it says the number of times that the boundary of an object winds around a particular point in the counterclockwise, that is nothing but anti-clockwise direction. The interior points of a two-dimensional object can be defined to be those that have a non-zero value of the winding number. So if the winding number is a non-zero value, then that particular point it belongs to a interior region. So that means which says that if the winding number is 0, then that particular point and that region is an exterior region. Okay, next we'll see how to find this winding numbers. So if you look at this, the procedure to calculate the winding number. So to do this, I need to show the direction for each edge. If you look at the polygon from point A to point B, these are the first 2 points, so the direction is from point A towards point B, and then from point B to point C, and then from point C to point D, and point D to point E to point F, and from F to G, and from G to back to A. So these are the directions that has been assigned for each edges of a polygon. Now we'll see how to find the exterior and interior region, for which we need to have count of winding number. So first we'll initialize the winding number to 0. So winding number is initialized to 0. The second point, imagining a line drawn from any position P to a distant point beyond the coordinate extent of the object, that is from this point we have drawn a line towards the outside of the object. So chosen line must not pass through any endpoint coordinates, that is you should not pass through any end point coordinates, that is either from C or from B or from A. So you should not pass a line through the endpoint coordinates, something like this, it is somewhere like this. Okay, so next, so as we move along the line from position P to the distant point, count the number of object line segment that cross the reference line in each direction. So the difference here is, earlier we just in the first algorithm we were counting how many line segments are going to intersect, but here we also have to take care of the direction of those line segment that crosses our reference line. So here if you take this line, there are two line segments, that is one is from A to B and the direction is from right to left, right to left, and one more line segment is C to D, which is left to right. The direction is left to right. Okay, next point, add 1 to the winding number every time we intersect a segment that crosses the line in the direction from right to left. So if at all you have a line segment crossing our reference line from right to left, which is nothing but anti-clockwise or counterclockwise direction, we need to add 1. If the line segment direction is from left to right, then you need to subtract by 1. Okay, next, the final value of the winding number is non-zero, then P is considered to be an interior point. Otherwise, that means if the winding number is 0, P is taken to be a exterior point. Okay, so first we'll see about this reference line that is there. So here the one line segment, that is A to B, which has a direction from right to left. So if it is right to left, we will add 1 to the winding number. So the winding number is 1. Next, the one more line segment is that we have from C to D, which is from left to right. So when it is left to right, you need to subtract by 1. Already we have the winding number as 1, so subtract by 1, so that becomes 0. So we don't have any other line segments intersecting our reference line, so the winding number becomes 0. So if the winding number is 0, then the conclusion is that that particular region is an exterior region. So this will be an exterior region. Okay, now next we'll look about the interior point, which is being drawn here. From here to here it has been drawn. So there are two line segments intersecting that point. One segment is that from F to G, one segment is from F to G, so that has a direction left to right, and one more line segment is B to C. So B to C in this direction, again it is from left to right. So what about the winding number? So the first line segment, that is F to G, which is from left to right, so your winding number you need to add, when it is left to right, okay, you need to subtract by 1. So the winding number initially it is 0, so now it becomes minus 1. Okay, next, one more line segment, that is B to C, intersecting our reference line. Again the direction is clockwise, that is nothing but left to right, so you need to subtract again by 1. Already the winding number is minus 1, so you need to subtract again with minus 1, so the value becomes minus 2. And we don't find any other lines intersecting our reference line. So the winding number is -2, and which is nothing but a non-zero. So the conclusion is that if the winding number is non-zero, then it is treated to be a interior point. Okay, so as a summary, you draw any uh, reference line from a point P of the polygon, and then see that it does not pass through endpoints of the polygon. And after that, you need to just check how many lines intersect the reference line, and those intersecting lines, if the direction is from right to left, then you need to add 1 to the winding number. If the direction is from left to right, then you need to subtract 1 from the winding number. And finally, check the value of winding number. If it is a non-zero, then treat that region where point P belongs to as the interior point, and if it is 0, then treat it as exterior point. So this is how we just identify if the particular region belongs to the polygon or not. Thank you.